All right, surface area. So pretty much looking at 3D solids. Okay, so the surface area of a solid is, basically it's the area of all the faces. So let's write the addition of the areas of all the faces. Okay, so addition of the areas of all the faces. Two main types: right prisms, as in there's a right angle, and oblique, which means obviously it's oblique, which is not a right angle. It is useful to consider the nets. So, for example, you've all seen before the classic net, like this. You don't have to do it like this, but it helps you visualize all the faces of a solid. All right, first question. So we have here the shape, the solid. Here's the net. So you can see if you fold it out, you've got 4 rectangles and 2 squares. So we need to find the area of all of them and then add them together. I might use some color coding to help. Let's make these ones green, and we'll make the other ones, say, blue. So 2 greens and 4 blues. So areas, so total area. So surface area equals, well, the green one, so 15 times 15. But of course there's 2 of them, so do that. That's 450. Let's put it in green. And of course we know the units. Okay, plus also, we also need to add the other 4 faces, which is 4 rectangles. So it's going to be 35 by 15. So we're going to plus, so 35 times 15 times by 4, which I believe is 2,100. So therefore total is going to be 450 plus 2,100. So 2550 square millimeters. All right, part B, we're going to assume this is a cube. It really should actually have this. Okay, so cubes have 6 faces. They're all going to be squares. So surface area equals 1 square is 144 by 144, but you need 6 of them, so times that by 6, which is 124, 416 square centimeters. Part C, rectangular prism, but it has an open front, so we're not going to actually include this face here. So with 1 face left, this has 5 faces. So SA equals, all right, so we got 1 of these faces, 2 of these, and 2 of these, because the sides are the same and the top and bottom are the same as well. So let's start with, say, these ones here. So it's going to be 7.5 times the height, which is 3.4. There are 2 of them. Yep. Then plus. Okay, the next bit, we have the front. 5.2 times 3.4. Normally we would times by 2, but there's only 1 of them, so we can leave it as is. And then we also have top and bottom. So 5.2 times 7.5. So again, what we did, 1 of these, which is this times this, 2 of these, which is this times by this one here, and these are the same, and then this, so it's 7.5 times 5.2, but also multiplied by 2. So the only one that's not doubled is this one, because we are told it's an open front. Now just type these all up separately and add them up for your final answer. I'll just type them up myself, so 7.5 times 3.4 times 2. So this one here is 51. Second one, 17.68, 78. So grand total of 51 plus 17.68 plus 78, 146.68. square meters. Alright, part D. Here's the triangular prism, here's the net, 3 rectangles and 2 triangles. But we also have a missing side. So obviously there's right angles here. We're going to use Pythagoras to work out what x is. Let's start by doing that. Now, is that a short side or a long side? We're finding a short side, so it's a subtraction. So I'm going to write a squared plus b squared is c squared. We're going to have x squared plus 12 squared equals 13 squared. X squared plus 144 is 169. X squared is 25. So x is 5. That's the first part. So this here is 5. These are all 5. Let's now do a surface area of 3 rectangles and 2 triangles. You can see these two are the same. These two are the same, and then this one here is different. So SA equals, let's go 14 times 5, which is this one right here. Then we have these two. So that's going to be 13. And wait a second, these are actually not the same, my bad. These are actually different. So this one 13 times 14. So 13 times 14 plus this one at the top, which is 12 times 14. And then we have 2 triangles. So in this solid, only the triangles are the same. So base is 5, height is 12. So that's going to be 5 times 12, but it's a triangle, so you've got to halve that. But there are also 2 of them, so they actually times by 2. In essence, these actually do cross off, but I'm going to write down everything still so that the whole process is there. You're then going to get all those answers and add them together. So let's just do them. So 14 times 5, so 70. 13 times 14, 182. 12 times 14, 168. 5 times 12 times half times 2, 60. Add those all up, and you should have your grand total of 480. So 480 square centimeters. So sometimes the harder questions like these have a hidden Pythagoras. So yeah, the triangles, you need the base. We have the height. We have the hypotenuse, but we need the base as well to get the area. Alright, part E, trapezoidal prism. So trapeziums and a series of rectangles. These are the same. Obviously this here is different though. Remember area of trapezium, so area equals h on 2, a plus b. Alright, so surface area equals, let's start with the trapezium. So the height is h, which is perpendicular height, which is 12. So 12 on 2, bracket, top plus bottom, so a plus b. But there are 2 of them as well, so times by 2. So far we've done these 2, but there's more to come, so plus. We've got this rectangle here, so 13 times 40. Also the rectangle on the other side, which is 15 times 40. And the top rectangle, which is 10 by 40. These are all plussed. And then we also have the bottom one, which is 24 by 40. Like before, add them all up and you'll have your grand total. This is 408, 520, 600, 400, 960. Grand total of 2888 square units. Okay, so nets, if you're confident without them, you actually don't have to use them unless the question actually asks you to, but it is a good way to see, to make sure you get every single shape. So area of all the individual faces, add them all up, and that is your grand total. And of course, if there are two of them, like the trapeziums, you've got to double them. But in this particular shape, all the others are different, so there's just one of each one. Okay, so that is surface area.